Okay, ladies and gentlemen, now for something completely different. This is going to be partial fractions. This is something you likely have never seen before, so pay close attention. It's going to be addressing a number of Common Core standards. One is to write expressions in equivalent forms to solve problems. The other is to represent algebraic rational equations in multiple forms. Both of those Common Core standards are hit here. Primarily for your purposes, it's also going to be used in calculus, because if you can break up a complex function into two more simple functions, then you can more easily do calculus on the simple functions. Now, what we're really doing here is we're going to take this, we're going to break it down into two pieces. So instead of having one fraction, I'm going to end up with two fractions. Now, to do that, it's really the reverse of the following. If I were to take 1/2 plus 1/3, to add those two fractions together, I'm going to have to find a common denominator. So I'm going to find a common denominator of 6. To do that, I'm going to have to multiply the first fraction by 3/3, the second fraction by 2/2. With that, I end up with 3/6 plus 2/6. Finally, I can say, well, gee, that's 5/6. What we're doing is we're going to take 2x plus 5 x squared minus x minus 2, and they've given us the answer. What they haven't given us is what two things went together to make it, especially not in some sort of unreduced form that it may have started in. So we have the common denominators that are required to achieve this. We don't know them. Well, the easiest way to break down a fraction is much like the 6 can be broken down into 2 and 3. We can break x squared minus x minus 2 down into its factors, which are x minus 2, x plus 1. So those, just like the 1/2 and the 1/3, are the two fractions that originally came together to make this. Now, I don't know what the common denominator bit is, but I know that that's where it started. My problem is I have no idea what goes on here. That's what we're going to be solving using partial fractions. Now, so what I'm going to do is at some point I need x minus 2, x plus 1. Don't know what that is, don't know what that is. So I'm going to find some missing pieces here and here. The way we do this is using Oliver Heaviside's method. Yes, that was the dude. That was the dude's name. I certainly hope he wasn't fat. So, Oliver Heaviside, he also came up with the finger method. Yes, the finger method. So, Oliver Heaviside came up with his finger method. That's right, his finger method. So what we're going to do is we're going to take this problem. We're going to rewrite it in its factored form with them still together, just like 5/2 times 3 in the previous example. The method says to find the term that goes over the x plus 2, or sorry, the x minus 2, figure out what makes x minus 2 0. Well, obviously, what would make x minus 2 0? Positive 2. Use your finger to cover over the offending term and plug in 2 everywhere else in the problem. If I solve this out, that gives me 9/3, or just 3. That number is what goes on top of whatever is under my finger. So I have 3 over x minus 2. I'm going to do the same thing for the other one. What would make x plus 1 0? -1. So I'm going to cover it over. Plug in -1 for every remaining x. And that brings me to 3 over -3, which is -1. Since I plugged in the -1, that's what it goes on top of. That is now broken up. Your purpose for this is if you were given an integration of 2x plus 5 over x squared minus x plus 5, x minus 2, and we're told to integrate this in calculus. This is hard. This, on the other hand, is easy. This is nothing more than 3 natural log x minus 2 plus -1 natural log x plus 1 plus c. This I don't expect you to be able to do. What I'm showing you is what you will do with it once you learn the Heaviside method. Here's another example of the Heaviside method used to factor a otherwise combined problem. First things first, it's going to factor the bottom. That's going to be x minus 2, x minus 1. If you plug this together, FOIL it together, it turns back into this. So we know it's going to be something over x minus 2, something over x minus 1. To find out, we need to write it in its factored form and plug in whatever makes this 0. What makes this 0? 2. So cover it over, plug in 2. 6 times 2 minus 3 over 2 minus 1. I come up with 9 over 1. So 9 goes here. Cover over the x minus 1, meaning I'm putting a 1 in. 6 times 1 minus 3 all over 1 minus 2. Answer turns out to be 3 over -1, which is -3. And it goes on top of whatever I have covered. And there it is. Nothing more complicated than that. Here's another type of partial fraction problem, but unlike the previous problem where the top was to the first power and the bottom to the second power, making it a proper fraction, this is an improper fraction where the top is larger in power than the bottom. The nice thing is, like any mixed number, you're going to have some sort of large number out front, and it's simply going to be plus some version of a fraction. What we need to do is get rid of the large number out of here, in our case the large algebraic expression, leaving just the fraction to deal with. The way to do it is exactly as it says. Whatever the top is, divided by the bottom. So here we go. -3x cubed plus x squared minus 9x plus 4. We're going to divide it by x squared minus 4x. Long division. It's back. Here we go. How do I turn this into this? The answer is -3x. If I multiply it by one piece, I have to multiply it by the other piece. -3x cubed plus 12x squared. Don't forget, when you're dividing, you must now switch the signs. This goes to 0. This becomes -11x squared. Bring down the -9x. How do I turn this into this? That's going to take a -11. So I'm going to multiply this by each piece. -11x squared plus 44x. Again, don't forget to switch the signs. Doing that, this goes away. This gives me -53x plus 4. Now, there's no way I can turn an x squared into an x, so what I have is -3x minus 11 plus the remainder, and that remainder is -53x plus 4 all over x squared minus 4x. Now, That part is done. It's broken up. What I'm concerned with is this part. I need to break this up. So for now, ignore the whole rational expression in front of the curtain, and let's deal only with the fraction. To that end, we can use Heaviside's method. Negative 53x plus 4 over a factored version of the denominator, x and x minus 4. All I have to do now is plug in 0 everywhere I see x. And I come up with 4 over negative 4, which is negative 1. I'm going to cover over this and put in 4. So now we come up with negative 53 times 4 plus 4 all over 4. So negative 53 times 4, enter, plus 4, enter, divide it by 4. Come up with negative 52. So my final answer is, bring down what you had to begin with, plus, and this fraction broken into its two parts would be negative 1 over x plus negative 52 over x minus 4. Now, of course, anytime you have plus negative, you can change it to minus, but in this case, we're not concerned with that. The only other problem that we have is when you have multiples of this same factor, but we're not going to deal with that in this class. This is going to be your answer. Your homework for this section, page 402, numbers 1, 3, 9, and 11. These problems here that I've listed, they are in your book. You can go and use your book. Use the examples in the book. You may go and use the video that you've already seen. Go back and rewatch it. I'll do it as many times as you want. Hit start over. You could also just pause at the end of this and write down the problems. These are the ones that are going to be due in class.